Hello and welcome to the third part of this SDL game framework programming tutorial. Last time we have created this CEvent class, and here it is still, CEvent H, CEvent CPP. Both files have been created and I've compiled it, make sure that it compiles okay. What I did is I basically went right here to build and compile current file. That lets us check if the file is free of errors, even though we don't have a main program or anything like that. So the next step would be to define what's called a game state class. Now let me tell you just a little bit what a game state is. Well, when you are writing a real game, think of an actual game out there. You know, whichever game that comes to mind. When a person starts the game program, you see that what you get is first you get like the intro video, right? Or maybe actually first what you get is like a splash screen, and then maybe an intro video, and then you get like a menu screen where you see the start new game and load game and options and so on and so forth. And finally, you get the actual game when you say start new game and select your character parameters and all that. You get the actual game. Well, these are generally known as game states or application states. So basically it's going to be, the framework is going to incorporate several states, several distinct kind of games in one game, basically, because every one of these states is going to respond to events differently. See, we just made the event class here. And we have the on key down, on key up, you know, stuff like that, L button down, right button down, all of that stuff. And all of our states are going to each differently respond to these things. Like, for example, on the menu, pressing the enter button might mean enter into that particular part of the menu. In the actual game, the enter button might mean to fire your guns or whatever enter button whatever you set it to do. So the idea here is to create a way for what's called a game state manager, for it to be able to switch the game state on you, and each one of these game states is going to be the kind of the game in itself, if you know what I mean. Like, it's basically going to be, each state is going to be its own separate game, and we're going to create a way to switch between those states. So first of all, we need to create a generic game state class. This is what I'm doing right now. I'm going in, I'm creating the header file, and I will call it, just according to my previous naming routine, I'll call it CAppState. So C application state, okay? And I'll go here. Once again, I'll shorten this header guard to CAppState H, and I'll add it to debug and release. So here's my class, right? Now, this class is going to be a fully virtual class, okay? Now, I know we already talked about, we said CEvent.h was virtual because it has like all these different functions in it that are virtual. This one is actually going to have only virtual functions, and what's more than that, it's going to have pure virtual functions. That means that this class is not going to be designed to be instantiated at all. It's going to be inherited from, like the other one. This one is also designed to be inherited from. The difference is that we basically are going to we're not even making a class, we're making kind of a blueprint of the class. We're creating a common type that we're later going to use in a polymorphic kind of way. We're going to create this class, right? CAppState, right? And I will define it to inherit from CEvent. Now, this would be my cue to go ahead and include CEvent, by the way. So, CEvent, now that's included. And this class AppState is going to inherit from CEvent. Why? Because we want it to be, we want the app state, we want each app state, regardless of which app state it is, to be able to process these events that we've defined here. So, and to be able to call on event and figure out which event needs to be called. So we go here to CAppState, and we define this class. It's going to inherit from CEvent, and it's going to have 4 functions in it, just 4 functions. They're all going to be pure virtual. Now, pure virtual means, because these right here, these aren't actually pure virtual. The reason why they're not pure virtual is because they have a body. You see, this function, for example, on exit, right? Look at this function on exit. See, it's got an actual function defined. Yeah, it's blank. Sure, we left it blank here. but it is still an actual function. So technically, you can inherit from this class, the CEvent class, and you don't have to define onExit. You don't have to define any of these, in fact. You can define whatever you want, but you don't have to define any of them. That way, the reason we did this is so that when we inherit from CEvent, we can decide which, if any, of these events get actually handled. Like, for example, I want to handle the left mouse button, and I want to handle the key press. That's all. I don't want to handle the middle button. I don't care about the middle button. I don't want to care about the right button. And mouse move, okay, I want to handle the mouse move. So it allows me to pick and choose. In this case, we're going to make functions pure virtual. What that means is they are required to be implemented in the overriding class, because here they actually don't exist, not even the body, anything. All it is just a blueprint of a function. So here our first function is going to be called onActivate. Okay, and this function is going to describe what happens when this event state, when this application state gets first entered. Like if any of that, basically it's going to be like a constructor, kind of. It's going to be a function that defines all the different variables that get set for that app state whenever it's entered. So whenever the user first enters the menu, all the kind of things that need to be defined right there. The next one is going to be called onLoop. Okay, sorry, onLoop. This is going to be the main function that's kind of going to be the main function of the application state. This is going to be that function that performs all the calculations but doesn't actually draw anything to the screen. This is kind of the function that will happen. That's why we call it onLoop. It'll happen later. I will introduce you to the idea of a game loop. We're going to have this big loop basically that's going to cycle through over and over and over and over and over and over again till the user presses exit, and gets out of the game. So every loop that happens in the main game program, we're going to reroute to the onLoop of the current game state. And so the current game state will then perform all the necessary calculations right here in the onLoop. The next function is going to be called onRender. Okay? onRender. And right here, there's this is going to be the function that actually draws everything. So these functions are going to be working together in tandem, in unison. For every loop, what's going to happen, every loop, every turn of the main game loop, first onLoop is going to happen, and then onRender is going to happen for the specific app state that we're in, right? Now, there's going to be one parameter to onRender, and that's going to be the SDL surface, and I'll call it target, whatever, right? SDL surface, that's going to be, I'm not sure if we've covered that, but I'm sure if you're at least a little bit familiar with SDL, you'd know what SDL surface is. SDL surface basically describes any surface that you can draw on, or that you can paste or blit other surfaces on. So the reason why we give it here as a parameter, and it is a pointer to SDL surface, because that's how SDL surfaces are usually allocated. They're all allocated on the heap memory, and not in the stack memory. So we always access them by pointer. So we will pass the actual main window surface where that needs to be drawn. Excuse me. This is basically the destination where the stuff is going to be rendered. And so the main program will pass the actual surface that is created to be the main window to this function. And finally, we have this onDeactivate, which is the exact opposite of onActivate. This is kind of the destructor. This is what's going to happen when the event is exited or switched to a different event, right? So, oh, I'm sorry. I apologize for that. I said event. When the application state is switched to a different application state, that's when this onDeactivate is going to be called. So, now, I did mention that these functions are going to be pure virtual, which means that not only do we have to add this word virtual to the beginning of each one of them, virtual, 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 and virtual. We also do this little thing, which I'm not sure if you're familiar with, but I'm hoping you are. You are going to be now anyway. You add this equal 0. I know it's a bit of a weird syntax, but it's equal 0. You write equal 0 after the end of the function. Okay, so it almost looks like you're assigning 0 to it. You're actually not. That's a syntax of C++ that indicates that this function should be treated as pure virtual, which means that now that we did this, the the compiler is actually not expecting us to provide any sort of implementation for this stuff, right? So there's not going to be any implementation. There's not going to be a body like we had over here with these CEvent functions. With these functions, there's not going to be a body. Now I am going to include a constructor and a virtual destructor in here, just because that's a good habit to have. So I'll say CAppState, which is going to be our constructor, and virtual destructor. That's kind of a, it's not as important in here, but you really should get into the habit of doing this. Every time you make a virtual class, or the class that's going to be inherited by other classes, it is very good practice to have a virtual destructor there. Now, I know that last time I split this across 2 videos. Right now I really don't see the reason, because this class is very, very short. So I'm going to go ahead and create the CPP file. Oh, and by the way, I almost forgot. As you see here, we used part of SDL, SDL surface, and the compiler is not gonna see that unless you also include SDL. Include SDL.h. Now, for those of you who don't understand why we're doing it a second time, this file right here already includes SDL. But these classes are they are independent of each other as of right now. I mean, yes, CAppState inherits from CEvent. That's fine. Actually, now that I think about it, since it inherits from CEvent, you really don't need to include SDL.h here. But it is a good idea nonetheless. Generally, the classes should include everything they're using. So if this uses SDL, we should include SDL, even though it already includes SDL through CEvent. See, it's not going to include it twice. That's why we have these header guards here. We have these header guards for a reason. These right here, the if not defined CAppState, and these here, these are not just idle, programming. They're there to prevent multiple inclusions, or to prevent what's called an infinite inclusion loop. So like, just because this class already inherits, SDL, and it also inherits CEvent. So if these weren't here, then SDL.h would actually be included twice, and we don't want that. We want it to only be included one time. So but I choose to do it. I guess you really don't have to put this include SDL.h, but it looks good to me, so I'm gonna leave it. And so now what I'm going to do is I'm going to actually define a CPP file to go with this CAppState.h. But that CPP file is actually going to be quite small. Very, very small, in fact. CAppState. Because, let's see, debug and release. All that's going to have, really, is the definition of the constructor and the destructor, and both are going to be blank. So that's like very, very easy. All we do is CAppState, and empty body, and then CAppState and destructor CAppState, and an empty body. That's it. Wow, that was a complicated file, wasn't it? That's really it. That's all we need to do for the CAppState. Now, as I've said, this CAppState is actually the abstract class that the real application states are going to inherit from. So this is basically providing a blueprint for a class, which we're going to have different classes for our CAppStates, for our different app states, and they're all going to inherit from CAppState, which also means they're all inheriting from CEvent. See how that works? So now we can create a whole bunch of classes that are going to be inheriting from CAppState, like CAppState game, CAppState menu, CAppState intro, CAppState what have you. And all of these things will inherit from CAppState. And what this will mean is that every one of these functions, these virtual void, these pure virtual functions, are going to have to be overridden in that overriding class. And obviously they're going to be defined. They're not going to be blank. There's actually going to be real stuff in them, because whatever event is, we want it to do something on activation, we want it to do something on loop, we want it to do something on render, and finally we want it to do something hopefully when we deactivate, right? So I'm gonna stop this here, and the next video is going to talk about I'm going to talk about how to create an actual event state that inherits from this. Okay, and I will see you next time. Thank you very much for watching.